Today, what I want to talk about is really how do we go about improving critical chain project management. Now, for many of you, you may say that you've gotten great results using critical chain, and this is true, and we'll talk about that in a little bit. That and same at realization, we've gotten tremendous results from critical chain. And as one of the pioneers of really the software, not only the software, but also how to implement critical chain project management, you know, we felt that there was still something missing, or really that critical chain wasn't completely sufficient. And so what we found in the last few years is that with CCPM 2.0, not only can we make the implementation of critical chain much easier, but also we can make it much more sustainable. And the customers that have used this or have implemented the new critical chain 2.0 have found additional gains even above what they achieved when they first did the critical chain project management implementation. So I hope you find this webinar useful. Whether you are already using critical chain and you're looking to maybe improve it, get more results, make it more sustainable, or even if you haven't done critical chain project management and you're just looking for the improvements in your organization, uh, I hope you find this useful today, and let me get started. So if we look back at the history of project management, there really hasn't been a lot of innovations that have happened. And of course, in the early 1900s, somewhere between 1910 and 1915, we introduced, or the Gantt chart was introduced. And that really became the standard for how project management or how projects were managed going forward. And before that, there was a very small handful of architects and maybe some engineers that were, managing their projects. But this idea of project management really didn't come about until we got the Gantt chart. Until then, we've improved computers, servers, we've had more horsepower, bigger projects, more details. These things have happened, but there really hasn't been a huge innovation in the approach to managing projects. A lot of detail, list out the tasks, identify what people need to do, and now, we'll try to make sure that we're keeping the project plan up to date. Then in 1997, Dr. Goldratt introduced the idea of critical chain project management. And really, this was building on the theory of constraints and what he had done in manufacturing to really bring constraints-based management into the project world. And he did this by first introducing the idea of buffers, right? Being that instead of the hidden safeties in tasks, everybody assuming that, well, maybe I can do it in 5 days, but because of all the problems, I better give myself 10 days to get it done. So he made this idea of safety something that you could visualize and something that people could use and share throughout the project. And then because of the buffers, now we were able to finally have really a computational way of coming up with priorities, or what he called buffer management, right? Making sure that people in the organization understood what was the most critical thing to work on. And this was the first step in really trying to bring the idea of alignment or synchronization also across the different resources. So instead of it having to be an art where supervisors or managers would get together and daily try to schedule things, really tried to apply an algorithm to make this happen. Then along came realization. And really for the first time, we started to understand, how do you apply this idea, not in a single project where Dr. Goldratt started, but how do you apply this in a multi-project environment? So the idea of now pipelining, taking constraints-based scheduling from the individual project to the pipeline was born. And along with that, of expanding this idea of buffer management and task priorities to a multi-project. So now not just about individual work stream priorities, but across projects, how do I need to be allocating my resources? And then finally, as I said, realization has not only been the pioneer in the software side, but also in how to go about implementing critical chain. Right? So for about 10 years, we focused very heavily on standardizing how you go about implementing critical chain in an organization. This idea of using the constraint to understand how much work can we really have, the work in process, what should be the right amount. The idea that full kitting, there's some work that's really not part of the project, but if we don't have all of that information, then the project's going to stall and we're not going to be able to get it done, even with the buffer, right? The buffer should be about the uncertainties, not about failure and preparation. And then finally, this process of task management. How do I make sure that people are getting work done as quickly as possible? How do I automate that? How do I bring it into the software and such? So at this point now, we had a very good process for critical chain project management. It was in the software. We were beginning to automate things. It was all available on the web. So, regardless of where people were working remotely, working in the office, they could quickly and easily find out what was the right priorities, what was the status of the project, and if there was any bottlenecks or constraints, what were those, and start to make decisions very quickly. But something was still missing, right? We've all faced this, that we've gotten great results, but then maybe the results fell off, or we spent a lot of time implementing, and then still we were missing some information in the project plans, or it was taking a lot of time, right? So even though we had significant results, right, it still just wasn't sufficient. Something was missing. And this is where we started to do some analysis within our implementations and talking with different people in the industry. And the first thing that we found was that really creating a project plan had become an art, right? It took people that had done it over and over again. It wasn't something you could simply sit down and think about, how am I going to do this project, right? Dr. Goldratt had given us some guidelines, right? He had said, okay, a project plan shouldn't have more than 300 tasks. Well, but what did that mean, right? Some projects they're very large, they're multi-year. How do you only have 300 tasks? Some projects are really small. They might only last 3 or 4 months. So now can I have a lot more detail and still keep it in that 300 range, right? So really the question was, what is the right level? And this fell to a handful of people, either in the critical chain community or within organizations, to try to figure out what is that right level. And this is why I said really it was more of an art than a science. And then finally, right, if you were trying to follow this, a few task guidelines, tasks should be between 5 and 10 days. How do I really schedule the daily work that people need to do? Let's say I'm in engineering and I'm doing a lot of drawings. How do I keep track of what are the drawings that are done, what drawings need to be done, when drawings might only take a few hours or maybe a day at the worst? For maintenance organizations, right? I'm doing hundreds of activities every day. To think that I can only schedule every 5 days, maybe it's too big for those kinds of organizations. Right? The second part was that, the nature of projects is they're uncertain and they change, right? Scope gets added. We try things and they don't work, R&D, right? We have to go back and start over again, or start at a different place, start a new work stream. So adding work, changing dependencies, this really became almost impossible for people to keep up with. Again, it fell to a few super users, if you will, in the organization that needed to be able to really understand the project, know how it was built, check the project out, and then add the work, make sure that I was getting the dependencies put back in the right place, rerun the critical chain or rerun the critical path of the project. Did I really get everything linked right? Did I get the result that I was expecting? And it took a lot of time. Sometimes the changes that they were trying to make would even be implemented in the field or in the lab. They'd already be done while the planners are still trying to put this information in the project. It was just taking too long. It was too hard to do it. And you couldn't do this on the fly, even if it was a small change. And the next problem was this idea of really, how do I synchronize at the daily level, right? The project plan wasn't capturing this level of synchronization to make sure that the organization across the different resources was really focused, right? It meant that people, leads, managers, they were having to hold daily meetings, sometimes even more than once a day. They were having to hold meetings on the side to really create these daily individual schedules to make sure that I had, the mechanical engineers, the electrical engineers, the people that were running analysis, that they were all in the right place at the right time on a daily level, not at the larger macro level of this 5 or 10-day activity. And finally, the fourth thing that we found was that the way buffer management was being done, it really made the project a little bit nervous, we called it, right? And what we meant by that was every time a task would finish, there was an opportunity now that it would move the resources either to another work stream because that had become higher priority, or even to another project because that was now higher priority. And really what it meant was that at this point, downstream activities were having to sit and wait. So people were following their priorities, but they were, quickly moving around to different activities, different work streams, or different projects, and the downstream resources were forced to just sit and wait. And really what it came down to is I just had too many red chains in the projects. So keeping this in mind that, we had implemented all of this good things with critical chain and what Dr. Goldratt had done. And now we've identified what we think are really where it wasn't a complete or sufficient solution. Right? We got to work a few years ago and started to think about what do we need to make a change. And really what we found out was that here's kind of the problem. That let's say the red tasks are being done by one of my resource groups. Mechanical engineers, if you're in the engineering, could be sheet metal workers if you're in the MRO, or some type of artisan in the maintenance world, right? And you can see that now, the top represents one chain of work that they had to do. Maybe this was designing one component in an engineering environment, and then I had a second chain that was designing a second component, and even a third chain to design a third component. So this is going through all my design, my analysis, drawings, creating bill of materials, this type of work. And quickly what we found out was that, resources were first working on design number one. Then when they finished that, the next priority was to move to design number two. And so the traditional critical chain was actually taking me further and further away from resources being focused and spreading them thin. It was doing this really at what we found was at an organizational level. And so while this was great for planning, it really wasn't working at the execution level in the organization. And what was even worse was that, to build all of this, sometimes I didn't know everything 6 months from now, right? I had an idea, but I couldn't go to this level of detail 6 months from now. Okay. So I had a project plan that now was causing me to move too much. I had a project plan that in execution is probably going to change because of uncertainty. And it's probably going to change because I just don't know all the definition. And so really what we found was that we can't use these detailed schedules when we're in execution or for the daily task schedules. How do we really want to use the project plan or the critical chain and buffer management? Well, what we found was that we need to break the project into two levels. So we take all of this detail that we had, and now we want to break it into two levels. And really the first level, this is where we want to run the critical chain. Logically, we want to group tasks together, and we group them in two ways. And I'm going to go through some examples. First, a project plan, and then also some examples from different industries. But we want to group these tasks together by, is there any interactions? Maybe I have, if I don't design all of this work together, then I risk having rework later on, which might mean now that not only I need to group tasks because they interact, but I also need to group the work across the resources. Right? For engineering now, I need the mechanical engineers and the electrical engineers to be working together because, the motion or how a servo needs to work might change depending on how the mechanical design is done. That's going to change my electrical engineering side, right? Or for maintenance, right? Sheet metal workers in an aircraft, right? They might need mechanical artisans, or they might even need some hydraulic folks to be there to move components out of their way to be able to finish doing their sheet metal work. If they're not there, work starts and doesn't get finished. So I want to group these tasks into a higher level, and that is where I want to build my schedule. So it starts to turn the project into more of a process. Okay, turns it into from individual activities to now larger scope-driven tasks that I need multiple resources working for a significant amount of time. These tasks might be as large as even 30 or 40 days to complete an entire design and really be able to move on. And you can start to think now at the critical chain level, if I'm prioritizing at that level, now I'm not moving between work streams, right? I'm working for that entire 20, 30 days before my priorities are shifting. But now what do I do with the details, right? We talked about this. It wasn't sufficient that I didn't have all this daily information. So this is really at the second tier, and this is what we call the execution level, right? The second level is now we want to capture all of the individual work, even down to, a few hours for a drawing or a couple hours to remove a panel on an aircraft, right? We want to capture all those individual things. So here I've got an example of designing a gearbox in an engineering environment. And there's probably even more activities than what I've captured here, right? But I have to do load calculations. Now I have different designs that have to happen, from shafts to selecting my bearings, designing the case. I've got to do some load analysis, right? And finally, I've got to do all my drawings, my prints, detailing all those things out. And exactly the order in which I need to do them in is not something I can decide today and have it actually happen that way 2 months from now, right? So at the second level, I really am not trying to build a schedule or a critical chain at that level today. I'll let that happen when it's time to start the gearbox design. At that point, I'll let the team decide what order am I going to do these in, because it's going to change from what I picked today. And it might even change even once I start there, and that's okay, right? So at this higher level, at the tier 1 or level, this is where we're actually going to build the critical chain. But I'm still going to capture all the detail and make those assignments available to individuals. And I'll show you what this looks like So let me just summarize a couple of the use cases that we see for examples, and then I'm going to go show you what this looks like in the software. Right? So one place that we found that this works well is what we call interactive work. Right? This is really where I have a continual flow of information that's happening, between resources during the execution of tasks. So engineering, a great example, between my mechanical engineers and the people doing my structural analysis, right? They need to constantly be flowing information back and forth because it's going to change the design. Or maybe even just between two mechanical engineers, one that's designing a motor and one that's designing a pump or a gearbox that motor is going to drive. They have to continually be communicating back and forth. Okay. Places where there's a lot of interaction between resources. Right? So if I look at aerospace design, right, everything that I do affects the weight of an aircraft, and weight is extremely critical. I mean, of course, along with safety and making sure that the design is going to be able to removing fatigue and such, right? But here I have it where different resources are designing different things, and anytime that I make a change, everybody else needs to know about it. So if I'm in an area where there's a lot of interaction between two different designs, now I need the resources to be scheduled at the same time because they're going to be handing work off back and forth at a very high frequency. Then we'll talk about also what we call micro assemblies, right? Really figuring out grouping work together so that instead of just doing a little bit of one thing, a little bit of another, a little bit of a third, then coming back to the first, I get everything done for that first group of activity. So changing the way that I am flowing work so that I am getting things done at my integration points. Right? The other thing is that we know now that there's places where I need to be batching to save on my setups, right? So avoiding this idea of frequent setups and teardowns. I'll give you an example of when they're building a ship or working on a ship, the movement of a crane, how I want to group work around moving cranes, because moving cranes takes a long time. The fifth one here that we're going to talk about is enforcing an execution schedule, right? Sometimes I want the project plan to actually dictate the order in which I'm going to do things. Okay. And really that comes down to making sure that I can move on to the next downstream work as quickly as possible. But at other times, this is number 6, I want to group things together because I need some flexibility. At the time of planning, I really don't know which order they need to be done in, but I know they all need to be done before I can move forward. So I'll give you an example of that in a little bit. And then finally is really we want to be able to support this rolling wave or idea of agile, right? How do I have a plan that I can quickly change based on what I've been doing for the last few weeks as I move into the next task? So this idea of rolling wave planning, or really what a lot of the ideas around agile, how do we support the good things that are coming out of that and develop, or schedule some things now, and then really finalize and finish out the schedule when I get to it 2, 3, 4 months from now. So let me jump over to the software, and then I'm going to come back and actually show you some slides on each one of these, or each one of these examples. Here I have a project plan. It's an engineering plan that is actually developing a solar panel. Solar panels for a large solar array, if you will. Okay, and now this project plan, this is a real project plan that a customer had shared with us, and this project plan before had about 120 tasks in it. This project plan has now been pared down to about 25 tasks, right? So again, we looked at how do we want to group those 120 together, and I'll be honest, they've even refined this more, and I think now they're down to about 18 or 19 tasks. Okay, and for those of you that have used Concerto or seen Critical Chain, you're familiar with the full kits. I'm not going to go into that. Really, what I want to go into is this idea of the 2 tiers. So as an example here, I have a task of generating this preliminary panel configuration. And in this case, it's going to take them about 20 days to get it done. And it's going to take them, for this one, a couple of mechanical design engineers to do that. Okay? But now I still want to capture the individual activities that people need to do. Now, in this case, this is not individual daily work, right? But this is, each one of these is an activity that somebody's going to do. If you're familiar with either aircraft maintenance or ship maintenance, or even shutdowns in a refinery, right? These steps may be your work instructions that you have to do. They may be only a few hours long. They may be hundreds of hours long, especially if you're talking about something like a shutdown for a refinery. But now we're listing down the hundreds of activities that need to be done, tens of activities or hundreds of activities that need to be done in order to complete this scope, and all the resources that need to do them. Right? And instead of trying to schedule all these individual activities, I can, in this case, I've created them just as parallel activities that once we start the task, we'll schedule the exact order for them. Okay? And each one of these tasks, from here now, has this same idea where I have a task. In this case, I have multiple resources. I not only have mechanical design engineers, I also have some structural analysis that has to happen. and I have some thermal analysis. Now, for those of you that are familiar with critical chain, you're going to look and say, wait a minute, my thermal analysis is only assigned to this activity for 2/10. This idea of having a fractional resource assignment. You're right. Some resources are just going to be dedicated to the task or dedicated even to the project. Some resources, this is the truth of projects, they're going to have to move. They're going to be coming in and out of projects at different times. But when I come down to, for this thermal analyst, when I come down to the work that they specifically need to do, at this point, they are 100% dedicated. So now it's still very important that I give them a correct priority. They know when they need to work, and they're focused on that. The larger, more important thing is that at this higher level, at the tier 1 level, when it's time to do this activity, all of those resources need to make sure that they're focused and working together to complete all of those lower tier 2 tasks as quickly as they possibly can. So now, right, the idea of critical chain, we're still applying the buffers, whatever percent we want to apply. In this case, I'm going to apply a 50% buffer. Okay. And Concerto is now going to apply the idea of critical chain at this tier 1 level. So it's going to run the algorithm. It's going to see where do I have conflicts of resources, and it's going to create now a schedule for each of my tasks. It's going to insert my buffers where I need them, and it's going to, in this case, the red, it's going to identify what is my critical chain. But you can see now I have a relatively simple project plan with very few tasks for where my schedule is being built. But all of that 120 line detail is still captured in here. It's just been grouped together. This now allows me during execution, without taking the project back out, to make changes very easily. The other thing is that at this level, with only having a few tasks, now this really becomes a simple template. Any project where they're going to build a solar array is always going to follow this flow. There might be small changes, right? Because the number of panels has to change, or the power requirement, which means it might need a little more design work up front. How long it's going to take to procure things might change. So durations might change, but the steps they're going to go through, these high-level tasks, they're not going to change. Same thing holds true for if I'm doing maintenance on an aircraft, right? I can now start to break the project into areas, and I'm always going to touch those areas. Sometimes I'm going to do more work there. Sometimes I'm going to do less work there. So the durations, the number of subtasks are going to change. The number of resources might even change that I need for that task. But the overall flow is not going to change. So by creating this as more of a process, now I have a very templatized environment that I can make projects from very quickly. If I move into the execution side now, right, what's going to change here is that my first level of priority is going to be at that higher tier 1. It's going to be those individual tier 1 tasks. And underneath this, now I can expand and see what is all the details that I need to do. And it really gives me the ability to now identify the individual resources that are going to do them by name, right? So now I have this print, and George is going to do that. In this case, I have a CAD drawing, and I can assign that now to an individual in the organization. The nice thing is that let's say that this product build, something's going to be different than what I thought was going to be there. Either I don't need some of this, maybe this IT work, I really don't need that. I can simply hear from execution without going back into the project plan, without going back to the project management office. I can easily remove activities from it, and I can also add additional activities if I need to. So I can add another subtask. And the impact of doing this is immediately going to be reflected, not in the remaining duration, but Concerto is going to roll it up to tell you how long it thinks it's going to take you to do this work based on the changes that you're making. Okay. Even if it was a significant change and I did want to go ahead and go back into the project plan, right? Again, I'm not changing the high level flow. I'm really just going to be changing these subtasks. So keeping the project up to date is now something that's not relinquished to just a few experts in the organization, but it's something that I can do very quickly. And when any individual logs in here, when George logs in, right, if I was to go and look at George, it's going to show me what are the activities that are assigned to him and give it to me in a priority order. You can see this is showing these are subtasks, that lower level execution work that George needs to do. So I can quickly see how much work I've assigned to George. We can generate reports now about, do I have resources that are overloaded? Do I have resources that are underloaded? Right? All this kind of information is quickly available. Not something for this webinar, but this is really the power of the idea of having this higher level task that now people are truly focused on. I'm completing that work before I'm moving on to the next scope of work. And I think, let me go back to Greg. I think that's an important thing that maybe I haven't quite covered, is that now at this higher level, right, I have a larger task. And before I finish this and move to the next, right, I've got to complete all of those subtasks underneath it before Concerto is going to go and reprioritize and move me on to something else. Right? So the buffer management becomes a lot more stable at this point, and it forces the organization now, all those resources, to focus on this one thing and get it done as quickly as possible. So let me jump back over and kind of go through a few of these activities, and then I'll take your questions or a few of these different ideas. So this idea of interactive work, let's say I'm designing a turbine, right? So this could be a turbine, aircraft turbine, jet turbine. This could be a turbine for a power plant or something like that, right? But I have different resources, different resource groups, my turbine group, compressor group, casing group. Of course, there's more, but this is just as an example. And in order to design, let's say, a turbine blade, right, it's really going to impact all of these areas. It's going to change the design of the case. It's going to change maybe even the design of my compressor, even though really what I'm doing is I'm designing a turbine blade. And if these activities are all scheduled on different work streams for each of those groups, or sometimes even in different project plans, trying to synchronize that and make sure that I've got all those designs going on at the same time is very difficult. And if they're not going on at the same time, well, then what ends up happening is that now I end up having rework. I think turbine thinks they're done. Compressor finally comes along later and says, oh, wait a minute, I can't accept that design. You've got to go back and make a change to it. If it's late enough, I may have even sent it off for manufacturing, right? So not having these synchronized means that not having all of these resources focused at the same time means now I've compromised later on and caused my project to delay and stretch in length. Okay? The solution here now is I don't want to schedule each of these activities separately. I want to create one task for this blade design, and I want to capture each individual resource group's work that needs to happen underneath that. Right? So in this case, I'm going to have one task for blade 1 and all the iterations that they have to do, as well as one task for blade 2 and all of those iterations. So nobody moves on to the next blade until the first one is completed, and so on. So another example of interactive work, right? This is, this comes up quite often in engineering and procurement, where maybe I have different processes by which materials are going to be made. In this case, I need to get some castings made, right? So aerospace, maybe I need to cast some frames or some stringers, but then I also have to design the clips, mountings, fasteners for how do I run the hydraulic lines, how do I run the wiring, how do I mount the panels on, right? And, of course, for those of you that have been around the industries, right, you know that castings take months and months to design, develop, pour, and produce, right? Yet clips and mounts that are maybe just stamped out of sheet metal or something like that, it might only take weeks to procure those, right? So now I have this problem where I think I need to develop the castings much earlier than I'm designing the clips and fasteners. The problem here is that if I've designed the castings and now for some reason the clip has to be redesigned or that fastener has to be redesigned because a weight problem or something like that, going back and making changes to my castings at that time is extremely costly, both in terms of money and in terms of time. Okay. So really what we're saying here now is this same idea of how do I group things. Now I want to be grouping what are those castings that are going to have clips attached to them and making sure that I'm designing the clips and the castings at the same time. So sometimes this idea of two-tier planning means not only grouping work that was scheduled to be done at the same time, but also grouping work together that has interaction. So looking forward in the project and pulling work earlier and actually eliminating some risk. Right? So now what I've done effectively is created 3 tier 1 tasks and working together on what are the castings that involve clips, what are the castings that involve mounts, and what are the castings that involve fasteners. Each one of these become their own. All the work for that, designing, testing, creating drawings, all that becomes, each one of those become their own individual tier 1 activity. So here's a case of this idea of interacting resources, right? And here's a situation where engineering sees this a lot. I have to do some designs, some drawings, and then I have to have a review. After that review, then I have to do some rework and I review it again. And finally, then at that point, I might get a approval. Okay. The challenge here is that the people that are needed to do the reviews, the people that are actually doing the work, trying to synchronize their priorities so that I can get this whole work stream done as fast as possible is extremely difficult, right? We've all heard the stories, right? We finish the design work, we finish the drawings, we submit them and they sit in somebody's inbox for a week, right? In fact, in the project plans, we even build them this way that we plan this review process to take 1, 2, 3 weeks in organizations because we know feedback's going to trickle in. We make changes. Again, it's going to sit in an inbox, right? So the idea here, though, is that how do we shorten this as much as possible, right? Now, again, we want to create this one work stream at a time and capture each of the individual steps, the drawings, the review, the rework, the approval, as individual steps underneath this work stream so that now if it's a number 1 priority for the drawing, for the engineer doing the drawing, it's also a number 1 priority for the team that's going to review it. Right? Helps to synchronize that priority, focuses all these people together, and now what was taking 2 or 3 weeks can actually get done in just a few days. This idea of micro assemblies. So this is an example from building a ship. But this happens in projects quite often, where for this case, right, a ship is broken into all these different sections, right? And within those sections now, right, one of the things that I've got to do is I've got to cut plates that need to be welded together. Okay? What typically ends up happening is once we have set up to cut that first plate, it may be very similar to the first plate in subsection B as well as subsection C. Right? So from a manufacturing perspective, what they want to do now is they want to start breaking down and saying, well, let me do all the plate 1s, let me do all the plate 2s, let me do all the plate 3s. The problem is now that I can't go forward and fabricate my subsections. I really can't get started on my section 1 fabrication. And now we're really stretched out by finally getting all of these plate cuts for any one subsection. Okay. So what we're saying now is, again, group them together, group all the plates together of a given section, get all of them done. Right? As soon as I've gotten them done, now we will move into the fabrication. Right? Focus not only the engineering, but also the manufacturing work, making sure that we're getting the designs for that section done, making sure we're getting the manufacturing for that section done before we move on to either the next subsection or the next section in the project. this idea of batching. This is an example of, right, moving a crane if I'm working on either building or the maintenance of a ship, be a submarine, be it uh, uh, even a cargo vessel, right? The movement of a crane is extremely time consuming, right? So instead of thinking about each individual pump or valve or electrical panel inside of the ship, now what I want to think about is what is all the work that I need to do inside of an area. Otherwise, I may move the crane to area one and end up pulling the pumps. Then I may move on to area two and pull the pumps from there, only to have to come back to area one to finally pull the valves, right? And while from a perspective of, the repair work that has to be done on those individual components, it may be that the pumps are the long lead, so I want to get them first, and then the valves, I want to get them second. But from getting everything out of the ship so that now we can start our repairs on the ship, if I'm constantly moving the crane, my cycle time is increasing significantly. So now what I want to do is I want to move the crane to that area, stage it, and make sure all the work is getting done. So all the resources that are required, whether they're mechanical resources, electrical resources, I want to make sure that they're all working together in that area and clearing it out completely before I move on to the next one. This third idea is enforcing an execution schedule. Right? So this is an example from building, commercial, or sorry, from building residential real estate. I don't mean individual houses. This is talking about building a large apartment building, right? And while it might make more sense for some people to think about, okay, I want to go in and do the flooring on all my bathrooms. So I've got 50 units. I'm going to go do flooring in bathroom in unit one, then the bathroom flooring in unit two, then the bathroom flooring in unit three. Then I'll come back and I'll start doing the kitchen flooring or some order like that, right? The problem here is that the downstream trades often can't come in, whether it's cabinets, whether it's painting, whether it's finish work. They can't come in until all the flooring is done. Right? So instead of allowing the work to flow a little bit in one room, a little bit in the next room, now I want the schedule to actually force some sequence in the execution. So at the same time, there's often instances where I need the sequence of schedule to be more flexible, right? And maybe that when I'm doing the planning, ideally I want to do some civil work. So maybe this is construction again. I want to do some civil design, then mechanical design, and then electrical design. The problem is that in execution, I may not be able to follow that. And they may actually be a little bit iterative where they need to be working together again, right? So now instead of creating detailed tasks for each one of these and linking them together, right? Now really what I want to do is group them as one design activity. And maybe it's not the entire design, but again, it's some scope of the design at a higher level. And I want to capture the individual work for each one of these to be done at the same time. The exact order in which it happens, right? That has flexibility they can handle because it's at the tier 2 level. They can handle that in execution. But the real important thing is that they're now focused and all working on this design at the same time to get it done as quickly as they possibly can. The final thing we'll talk about is this idea of rolling wave planning, right? And so, the easiest thing with Agile or best thing with Agile is to talk about a software approach where, here I want to schedule at a higher level of what's the design or development work that I need to do. And finally, what is the testing that I need to do afterwards? Okay. So instead of scheduling individual activities, now I want to first come up with what is the design of module one and what testing do I have to do. Now, as I finish that, I can start to add more details underneath subsequent modules in these later designs, right? Again, it's a process flow that I'm going to follow. I can schedule that process flow, but the details, the level 2 that we talked about, or tier 2, that's something that I can add later on during execution. So it allows me to build a project plan, allows me to have a critical chain, that I can get a projected date from, but slowly add the details as I know them. Right? Same thing true for engineering. Right? Until I finish the first design, I really don't know what's going to happen in the second design, the iteration. Maybe I have to do the preliminary design before I can do the detailed design. And until I finish that preliminary, I can't detail out I can't do the detailed design tasks. But I can at least capture it, know the resources that I think I need, estimate the time that I need, and now if there's changes, I immediately see what that impact is. And I can easily add what those details are. So I hope that this is the end of what I had. I hope this helped you see how changing the way that we plan the project from the detailed to this two-tier planning can help you focus the resources in your organization and complete work much faster, and also provide you with a much easier way to build and maintain the plans, as well as make things more stable. Right? A summary of the benefits that we see with the two-tier task. Again, this better focus and finish. I have more detail, and people can now see what is the work that they need to do, but it stays synchronized around completing a scope before moving forward. It also provides me a much more stable network. In other words, at that tier 1 level, it doesn't change. That is the flow in which you're going to go through. But it's also a lot more flexibility, because now at the tier 2 level, I can make changes very quickly. As an example, I'll go back a little bit. We've been running this now, kind of in the ideas of developing it. This has been going on for a few years now. We've seen projects where previously they had been rescheduling the project every year in the construction industry. As an example, they've been every month, replanning the project. We've now run projects for over a year without having to do any rescheduling of the project. They haven't had to take the project out and do replanning for over a year. Right? It's very easy to report progress now. Right? I'm really looking at that subtask level. I don't have to worry so much about remaining duration. I'm really looking at what am I working on and am I done with it? Sometimes they might be bigger, but a lot of the activities are simply what am I working on and have I completed it? Now I'm only worried about the roll up at that higher tier 1 level. Okay. The plans are also current. And if I have current plans, now the data that I'm getting about projected date, where are my constraints, what are the bottlenecks that are coming up, are much more accurate. Right? If I don't have an accurate plan, if it's not up to date with what I'm really doing, all the information in the future is probably worthless. Now, looking ahead, I can have confidence in what information I'm getting from the project plan. We can easily do this rolling wave planning that we talked about. And the final thing it does is it makes automation and integration much simpler. We didn't cover that in this one, and be happy to talk with people about this. But if you have an organization where you already have systems that are keeping track of things like individual drawings, right? So you have a PLM system for that, or you're in the maintenance industry where you have a system of record that's keeping track of individual work cards or individual operations that need to be done. It's very easy to integrate that work at the second tier, right? You can now communicate between Concerto and those systems, whether they're ERP systems, whether they're standalone systems, and we can share that individual activity work at the tier 2 level, right? And now, right, we have it makes creating the project plan much faster and much more simple. It also makes sure that our scheduling system is really in line with what's actually happening on the floor. So we can actually feed the information about what work is being completed and what new work is being added. At this point, I'll open it up to questions. Okay, the first question that I had is around Microsoft projects. So the question is, for organizations that are currently using Microsoft Project, can we continue to use Microsoft Project and still take advantage of the two-tiered approach. So one of the reasons, and I didn't go through this in the demo, but what you saw was that for the building of the project plan, it's now being done over the web. And one of the reasons for that was that we actually can't build two-tier plans directly in Microsoft Project. But that doesn't mean that you can't continue to use Microsoft Project. In fact, we can export projects between Microsoft Project and Concerto. But it's going to be at the tier 1 level. So, milestones, due dates, high-level tasks, that information will still be there. The second tier is something that's going to reside inside of the Concerto software only. It's not going to reside inside of Microsoft Project at this point. It just doesn't understand that two-tier approach. It's different than the summary that you see in Microsoft Project, because even at the summary level or with Microsoft Project, it can't schedule at the summary. It's still going to schedule at the level below. So pushing that information to Microsoft Project, now it's going to try to reschedule the individual tasks instead of scheduling at the higher level. I hope that answered your question. So the next question I got is, what kind of results are we seeing in organizations that have already implemented critical chain when we go back and apply this CCPM 2.0? So in organizations that have decided to move to this approach, we're seeing additionally cycle time reductions of 15 to 20%. And I think there's even more opportunity there, but right now that's what we're beginning to see. And not only are we seeing that kind of reduction in cycle time, then of course we're also seeing a similar increase in the throughput in the organizations as well. A third question that I got is a question, the question is, for in terms of the implementation, does this do anything to help reduce or simplify, so reduce the time, or simplify the implementation process? Yes. In the initial implementations that we were doing at Realization, our time frame was oftentimes several months, 4 to 6 months to do an implementation, and go live might have taken the first month and a half to 2 months before we could actually go live with the software. Because of turning the projects into more of a process flow, we've now been able to start with organizations, build the project plans, and actually go live within just a couple of weeks. Right? So we've significantly reduced the time to go live. And then in terms of the overall implementation, right, which is, there's some change management and things that can vary from organization to organization, but being able to go live and see results is happening much faster. Oops. I just got another one, but it's just a second here. I can't seem to read this one. There we go. Can you have a suite of standard project templates stored on Concerto instead of having an MSP template? Great, right? Yes. So Concerto stores individual project plans. As a matter of fact, not only now can we have project templates, so we can have each individual project now stored inside of Concerto, and any one of those projects can now be used as a template, or you can create unique templates to create projects from. You can do as many templates as you want there. We also have the ability to create what we call task templates. So maybe you have a task and you have some subtasks for it that you're going to use over and over again in projects, but not in every one. So instead of just creating instead of trying to create a separate template, you can actually create these tasks with their subtasks and store them to quickly and easily copy and paste into any project plan. So 3 levels we can do now. We can store projects, we can store templates, we can also store tasks as what we call task templates, ready to be implemented into any project as needed. Okay. If there's no other questions today, again, thank you very much for your time and joining me today. I look forward to working with you in the future and working with you to implement CCPM 2.0 in your organizations.